resolutions, which is kind of related to the size of the lens. I want to kind of walk you through this graph, which basically is plotting max optical resolution, or the kind of sensor size for current camera phones as the blue line, and sensor resolution as the red line. As you can see in 2010, basically there's a convergence happening where you have sensors, this is kind of like the megapixels, if you will, are out-resolving or outperforming the quality of the optics. A small lens is only so good. The old adage where basically engineers would just increase the amount of megapixels a sensor had will no longer work to improve cell phone image capture because a small lens is only so good. Additionally, camera phones lack the ability to capture 3D. 3D display devices are everywhere. They've been a big buzzword at CES last year and this year. But what's lagging are 3D capture devices to help augment these display devices. And especially small 3D capture devices that are also inexpensive to produce. Our solution is SLIC technology. SLIC stands for Structured Light Image Capture. And basically what we're able to do with our technology is capture both 3D information and higher resolution. When I say higher resolution, I'm talking about something that amounts to an effective doubling of the megapixel count, and we'll show you some actual lab results later on in the presentation. Our three main components for our technology are, first, our structured illumination source. This is what projects a pattern onto the scene that we use as our kind of secret sauce, if you will. Currently, we're using Pico projectors to do this, and we plan on developing a flash prototype in the future to replace current Pico projector technology. Second, we have the camera phone that's actually capturing the image. And third, we have our processing algorithm, which we plan to embed in the application processor inside these phones. We believe with the demand for 3D content, coupled with the need right now for improving quality and resolution for camera phones, our SLIC technology provides a great plan for us to go and license this technology as a business opportunity. This is a very complex problem. We've put together a large team coming from many different disciplines. Here we go on to our team. Jonathan Dietz again. I'm a JD MBA here at SMU. And beyond doing the legal work with the team, we're also going to help make sure everyone stays focused with the eye on the ultimate goal. Second, we have TJ Hill. He's our finance guy. When it comes to modeling out different licensing contracts with different cell phone vendors, he'll be our guy to make sure we maximize our profit. Next, we have Nick up with him, MBA with a marketing consulting background. He's really going to help us sell our technology to different camera phone vendors, along with our potential partners, TI as one example. And then we have two great management advisors to kind of augment some of our actual experience. Jack Baum is a serial entrepreneur. His last company, he partnered with TI to develop the MPEG-4 processing chip that allowed mobile devices to actually play video. We hope to emulate a similar plan and work with some of the same people his past company worked with. Viren Babar, a former TI engineer, MBA from SMU, CTO Tabletop Media, has 10 plus years of experience in the exact place we want to work with in TI. Additionally, we have a world-class technical team. Prasanna specializes in computer vision, and he's our lead inventor. Basically, his whole dissertation was on this exact technology. Second, we have Vikrant. He specializes in optics and is a co-inventor. And where his specialty will come into place is when we're converting from a Pico projector more of an optical-based flash unit, and he'll really help us innovate that. Additionally, we have three great technical advisors, starting with Indranil. He specializes in embedded system design. His characteristics will really help us when we want to partner with TI and get our software, our stuff, on their actual chips. As well, we have Professor Mark Christensen. He's the E Department Chair at SMU, and he's an optoelectric entrepreneur who has already created a company in a similar space. He'll be able to contribute his experience and knowledge in starting a company in the same kind of area that we're trying to start a company in now. And finally, we're very fortunate to have TI fellow Professor Panos Papamikelis. His background leading a world-class R&D team at TI here in Dallas and both Japan really help ramp up our R&D efforts into a world-class effort as well. I now want to talk to you a little bit about the business development and model. We've already developed our first prototype using off-the-shelf hardware, and we'll show that to you in the next slide. As well, we plan on developing a second prototype where we'll take existing camera phones with built-in projectors and putting our algorithm technology onto those and getting a working model in a small form, fitting, handheld type scale. Additionally, our third prototype will involve developing a flash unit to replace that Pico projector and really increase market adoption. Second, we plan on partnering with both application process vendors and flash manufacturers. We're already in talks with TI, and they've been graciously nice enough to give us, for free, several development kits so we can start working with them and getting our software more on their language to work on their chips. Additionally, we plan on partnering with a manufacturer, a company like Philips, who is a leader in the LED flash space for camera phones. Finally, how we're going to make money, as I mentioned before, we're going to license. Phase 1 will be the license to mobile users. These will be Nokia, Samsung, Google. These will all be potential users of our technology. And then our phase 2 will be to repeat the process and expand it into new verticals. We'll start off with licensing our technology to existing camera phones that have Pico projectors built into them, and then we'll move on to taking our developed flash and reaching a much wider audience on more phones. I'd now like to pass it on to Prasanth to talk a little bit more about Slick in action.
Thanks, Jonathan. So a few minutes ago, you heard Jonathan describe how Slick technology could help solve two problems that are associated with camera phones. The first is a limited optical resolution, and the second is a lack of 3D information. Now, what you're about to see is a video demonstration of Slick technology in action. Now, there are three components that are crucial to Slick. Now, the first component is basically the projector that you just saw a while ago. And the second component is the camera. And the third component is the Slick engine that's running on a laptop computer. So what you're basically seeing is the image. Let me actually go back a slide. Anyway, so what you're basically seeing is the image that the camera captures under pattern illumination. So now the question is, how does the Slick engine take these images? So basically what we're trying to do is project illumination patterns onto the scene. And then the hope is you can recover improved resolution and also depth map. So what I'm about to show you next is what this actually looks like. So what I want you to do is pay careful attention to the slide, the right half of the slide. So what you're seeing on the top is the image that is captured by the camera without Slick. So notice that the camera has trouble resolving the barcode. As a matter of fact, even if you were to digitally sharpen the image, the camera would have trouble resolving the barcode. Now with the aid of patterned illumination, by projecting these illumination patterns, what the Slick technology allows you to do is resolve the barcode. And the result is evident in the second image there. You can clearly see that the camera is completely able to resolve the barcode because of Slick. Now what is even more interesting is right below that you have a 3D map. Now what the 3D map gives you is a sense for the size, the scale, and the relative distance of the objects in the scene. Now the video demonstration that you just saw a minute ago was basically one of several prototypes that we've built for showcasing Slick technology. Now we've built other prototypes by using commercially available cameras and projectors such as DLP or LCD projectors and Pico projectors. Now the key innovations behind Slick technology are protected as patents, and they're protected by SMU's intellectual property policy. Now the really neat thing about Slick is that the scope of this innovation is not limited to camera phones. We can do much more with it. But there's a very specific reason we chose the camera phone market. So Nick here is going to try and explain why it is we chose the camera phone market.
So as Jonathan mentioned, we know that our technology will fill that void by increasing resolution for camera phones. Camera phones worldwide are expected to hit 3 billion in a couple of years, and really the mobile phone market is driven by growth of the smartphone. The great thing about Slick is it really fits well with the consumer trend going towards 3D technology. If you're at CES, then you guys know exactly what I'm talking about. And we really feel like the best way to get into those markets is to partner with a application processor vendor like TI or Qualcomm, and leverage their brand name, leverage their sales force. As far as competition within this space, there are 3D phones coming out that have 3D capture and display. The thing about these particular products is, number one, they're 2 camera systems, whereas Slick technology is a 1 camera system, so we're saving that valuable space on the board of the phone. And number 2, they're not going to provide that increased enhanced resolution that Slick technology will provide. And then, as far as resolution goes, we do feel like the compact digital camera is considered a competitor. However, everyone's moved away from using those as their main camera. Everyone's using their smartphone. So the beautiful thing about Slick technology is that it's really applicable in a number of verticals. We've highlighted a few: consumer digital cameras, surveillance and biometric recognition, and then there's the medical field that we can really add value to. TJ is going to walk you through some of our financial things.
Thanks, Nick. So as you can see on the graph behind us, it shows our projected revenues for the first 5 years of operations. And we have three different scenarios. Our base case scenario assumes that we're able to develop